So with over 17 years experience and numerous research that we've done in neonatal settings and in neonatal ICUs, we've realized that there's a necessity for accurate anthropometrical measurements and instruments in these wards. We find that anthropometrical measurements like weight, length and head circumference are either not done or not recorded accurately. Now, the implication of this is that it affects our nutritional prescriptions and our medication prescriptions that are all based on our weight measurements. Then for length and head circumference, these are so important for the long-term outcomes of these infants and for their neurodevelopment.
The major causes and reasons for missed anthropometric measurements, specifically for the preterm infant population, is due to the current and existing apparatus that we have available to us. We have narrowed it down to three main factors: user-friendliness, costs, and invasiveness. The first factor is user-friendliness. The current apparatuses available to us either only take one or to a maximum of two anthropometric measurements, for example, weight and length. Therefore, we require multiple anthropometric apparatuses to conduct multiple anthropometric measurements. The current apparatuses can be quite complex to use and therefore time-consuming. The current apparatuses are also not very user-friendly when an infant is connected to the CPAP device and if they're on an open or closed incubator. The second factor that I'm going to discuss is cost. As previously mentioned, multiple anthropometric apparatuses are required to conduct multiple anthropometrical measurements, therefore driving up the costs. The apparatus available to us can require and be made of quite sophisticated technologies, again driving up the costs. And lastly, the current apparatuses that we have available to us are all manufactured and made internationally, again being quite expensive in the South African market. The last factor I'm going to discuss is the invasiveness. Apparatus that we currently use require the infants to be extensively manipulated, so moved around in order for the anthropometric measurements to be conducted. The apparatus that we use currently require the infants to be removed either from the CPAP device or from the open and closed incubators. The major issues with this is that the preterm infants' core body temperature can drop, it increases their exposure to infections, and inevitably increasing their morbidity and mortality rates.
So the preterm anthropometric growth apparatus, or from now on mentioned as the PAGA, is a minimally invasive, all-in-one device that will be able to be slid underneath a preterm infant in an incubator so that they don't have to be removed. Also, we will be able to conduct all measurements, head circumference, length and weight, when infants are on CPAP.
The alpha proof of concept of the PAGA is able to conduct the following key measurements: weight, length, and head circumference. The next phase of development will be to develop the beta proof of concept of the PAGA. The beta POC will include the foot length of the preterm infant. It will also be able to plot the various anthropometric measurements, so the weight, length, head circumference, on the intergrowth charts. Therefore, dietitians, neonatologists, pediatricians, and neonatal nursing staff will be able to easily interpret the anthropometry of these infants. And lastly, the beta POC will also capture all of the data collected and import it into a cloud for storage.
Today I'm going to showcase our alpha prototype. On our yellow board, we have where an infant will be weighed. At the foot end, there are two ultrasonic sensors that measure the length of the infant and the headboard. Then we have a head circumference arm, which will measure the head circumference of the infant. And then we have our user interface at the side. I'm going to demonstrate how the weight of an infant will be done on the PAGA. Firstly, the PAGA is switched on, and then the weight measurement is pressed once. The infant would be on the scale and placed in the middle of the scale. It is busy measuring the weight of the infant, and you press the button again to capture that weight.
I will now demonstrate how the length measurement will be conducted. We will first get all the components in the correct places. So we will open up the headboard and remove the ultrasonic sensors, which is connected to the baseboard by a magnet. We will then position the infant with the top of its head touching the headboard and the infant in the supine position lying in the center, which is indicated on the baseboard. Once we are ready for the measurement to be conducted, we will then press on the length measurement button, draw the heels slightly towards one another. The ultrasonic sensors will then measure the length of the infants. Once the length measurement is stabilized, we will click on the length measurement button again to capture the length. I will now demonstrate the head circumference measurement. We will first remove the head circumference arm, which opens up, and with a magnet it connects to the base of the PAGA. The infant is already in the correct position, but just to make sure that the head is touching the headboard and that the infant is lying in the center of the baseboard. Once the infant is in the correct position, we click on the head circumference button. The ultrasonic sensors then conduct the head circumference measurement. Once the head circumference measurement is stabilized, we then click the head circumference measurement again to capture the measurement.
So looking ahead, the benefits of the PAGA is multifactorial, but just some of them are that it will reduce the cost of equipment that would be needed to be purchased for neonatal ICUs. It will improve the way that we work in a neonatal ICU by improving our prescriptions, which would include nutritional and medical. This will improve the outcome of these infants and their length of stay in hospital, thereby reducing total hospital costs. Also, it improves the quality of life of these infants. When they receive better care, they will have better lives. And lastly, it will improve and assist with biotechnology.
As the inventors of the PAGA, we would like to take this opportunity to show our gratitude for Stellenbosch University and Innovus. We would also like to thank our funders, the University Transfer Fund, as well as the Technology Innovation Agency.